Hello, algebra students. Today we are going to be solving systems of linear equations by substitution. And I want to point out to you that you already know how to do this. Look at this story problem that should look real familiar then to you. Betty is 3 times as old as Fred. So if I let B be Betty's age and F be Fred's age, I could say 3F is equal to B, right? Betty is 3 times as old as Fred. Okay, in 5 years, well, I'm going to need Fred's age in 5 years, and I'm going to need Betty's age in 5 years. She'll be twice as old, so for those to be equal, I'll need to double Fred's age, right? Now remember, you didn't know how to solve this equation because it was one equation with 2 different variables. But we learned that B was the same as 3F. Therefore, you could substitute 3F in for B. Okay, so we would have 2 times the quantity of F plus 5. That would equal 3F plus 5. And then I can solve it from there. I get what 2F plus 10 equals 3F plus 5. And then I could, let's see here, subtract 2F from both sides. And at the same time, I could subtract 5 from both sides. And I end up with the equation that 5 equals F. So Fred must be 5 years old. And then Betty must, of course, be 15 years old, right? Okay, that's substitution. Now, the problems that we see are going to look like this. They're going to say solve this system of linear equations. For example, y equals x minus 2 and y equals negative 7x plus 22. And we're going to have to solve this system. Um, what I'm going to do is I'm going to know that y is x minus 2. I'm going to take this x minus 2 and I'm going to substitute it into the other equation. And when I do that, I'm going to get x minus 2 equals negative 7x plus 22. And I'm going to solve for x. Add 7x to both sides. Add 2 to both sides. And my new equation becomes 8x equals 24. Well, heck, I can divide by 8. X is going to equal 3. Now I pick one of these original equations, either this one or this one, and I plug 3 in for x. I substitute it back in. Pick the one that's easier. I'm going to take this 3 and I'm going to put it in for x right there. So we get y equals 3 minus 2. Therefore, y equals 1. So my solution to this system is 3, 1. Okay, pretty simple stuff. By the way, notice I wrote it as a point. See if you can think about why I wrote it as a point. See if you can tell me tomorrow. All right, let's look at another example. Just a simple, hold on, let me get it written down. Okay, here we have another system. And again, we know that y is the same as 5x minus 2. So I can rewrite the second equation by plugging this in for y. Some of you might be wondering, could I have rewritten the first equation by plugging 4x plus 8 in for y? You sure could. All right, 4x plus 8. All I did was I was told that y and 5x minus 2 are equal to each other, meaning they're the same, meaning they can replace each other. And so I'll put 5x minus 2 in for y. Okay, I'm going to subtract 4x from both sides. And I'll add 2 to both sides. And I'll get x. Those will cancel. Those will cancel. And I'll get 10. So I know that x is 10. Now, I'll plug 10 in for x. I'll substitute it into one of those equations. I'll choose the second one. Really hard to make a bad choice in this problem. follow my order of operations and get 40 plus 8, 48. So the solution to this is 1048. Okay, now, what do you suppose you do in this situation? Here we don't know what y equals. We have a couple choices. We are going to pick one of the equations and solve for one of the variables. You could solve for x in the first equation, y in the first equation, x in the second equation, or excuse me, y in the second equation, or x in the second equation. Pick the one with the least amount of work. That will come out the prettiest. It looks like on the second equation, I could just go ahead and divide by 2 in all three places. So y is going to equal 7x plus 10. Now, that y is like that. I'm going to substitute this in for y into the first equation. And that first equation will become 9x plus 9y. Oops, I don't want to write y, do I? I want to write the quantity of 7x plus 10. Alright, and that'll have to equal 9. Now I'm going to do this problem and then I'm going to show you a shortcut for this particular one. I'm going to get 9x, I'm going to distribute and get 63x plus 90, and that's going to equal 9. And I'm going to combine my like terms here and get 72x. And then I'm also going to subtract 90 from both sides. And when I do that, I'm going to get 72x is going to equal negative 81. I'm going to divide both sides by 72. It's getting ugly. That's okay. It's working out fine. I know that 9 goes into both of these. I'm going to divide them both by 9. I'm going to get negative 9 over 8, negative 9/8. You could put negative 1 and 1/8 as part of your answer, but I'm going to use this improper fraction when I go to solve for y. Okay, now I can use this equation, or I can also use this one because this is just an altered form of number 2. I think the easiest one would be the altered form of number 2, so I'm going to use that. So I'm going to have y equals, what was it, 7x plus 10? 7x plus 10, but in x's place, I'm going to put this improper fraction here. That'll give me y equals 7 over 1 times negative 9 over 8, which isn't going to simplify pretty, plus 10. I'm going to combine my like terms here. Oh, excuse me, I'm going to multiply here. Negative 63 over 8, okay, plus 10. Now, I know 64 over 8 would be 8, so this must be negative 7, and I'm 1 short of where I need to be, so it must be 7/8 plus 10. So what's 10 minus 7? Well, of course it's 3. But now I have to take away another 7/8 of a whole. That's going to take me down to 2 and 1/8, right? If I had 8/8 being a whole and I took away 7/8, that would give me 1/8. You should be able to do fractions like this. All I'm thinking of is this 3 as 8 over 8. Oh, let me do that. I'm thinking of 3 as 8/8 plus 8/8 plus 8/8. Now I have to take away 7/8. Well, these two aren't going to get affected, so that's where the 2 is coming from, see? 8/8 minus 7/8 is 1/8. And there we go. So my y-coordinate is going to be 2 and 1/8. Okay? Now, I could have done one other thing I want to demonstrate here, and it wouldn't have made the problem like super duper simple, but I just want to make you aware of it. I could have divided this entire equation through by 9, giving me x plus y equals 1, and then I could have solved for either x or y. For example, I could have solved for y and said that y equals 1 minus x. Okay, that is another option. The answer still would have come out to be the same thing, sort of an ugly answer, but not really that difficult to get at. All right, so we first have to make sure one of our variables is alone. So we solve for either x or y in one of the two equations. And if we solve for either x or y, then we substitute it in. Of course, if y or x is already alone in one equation, we don't have to do any work. So then we substitute into the other equation. So what that means is if you solve for y in the first equation, you have to substitute what it equals into the second equation. If you solve for x in the second equation, then you have to substitute for what it equals into the first equation. And then you solve for the variable. You'll be down to one equation with one variable. All right, we're going to get some practice with this tomorrow. It's okay if you don't understand it 100%. It might take a little bit of time. Mr. Lawrence signing off. Good night, everybody.